Greetings, dear colleagues. Today, we would like to present our report on the topics Experience of Conducting Integrated Irregular Classes in Robotics. The modern high-tech society demands a deeper understanding of the principles of digital technologies, which is a prerequisite for successful self-realization and a secure life in the present world. The widespread adoption of technologies such as the metaverse, blockchain, the Internet of Things, big data, and others has radically transformed all shapes of society's life, as captured by the concept of Industry 4.0. Technologies and professions where engineering abilities play a primary role come to the forefront. Professionals with skills in modern technologies and a creative approach to problem solving are in demand in the job market. In the response to societal demands, the new challenges for the educational system include raising the level of scientific, technical, and technological knowledge for all layers of the population, professionals, and future specialists in various fields, including teachers and students. The increasing quantity and quality of technologies, especially computer technologies, make integrated learning with STEM projects using robotic devices a relevant educational approach. That allows increasing students' motivation to acquire theoretical knowledge based on partial activities and fosters an understanding of science as a factor in technical and social cultural progress. However, recent events such as COVID-19 and the war in Ukraine have significantly impacted the educational system as a whole, directly affecting all participants in the educational process. A strong stress, lack of communication with friends, new places and living conditions, challenging household conditions, including the absence of electricity and the internet, have become the realities for everyday life for many Ukrainians. The most vulnerable category is the children. Some of whom have lost their relatives were forced to move and start living in completely new circumstances. Different city or country, different teacher or online learning, different peer environments, and lack of communication, among others. The creation of STEM education centers where displayed children can communicate with their peers facing similar situations, meet in real life, collaborate on interesting creative tasks, acquire new knowledge, enhance their skills, and define their preferences and perspectives for the future and profession is an extremely important task. At the same time, researchers conducted a systematic literature review, revealing that STEM education develops skills that give migrant families access to economic and social benefits and contribute to social innovation process in destination in countries. Integrated learning projects are a form of organizing students' educational and cognitive activities within and beyond the school. Each session is focused on implementing a specific project and includes tasks related to research, construction, and programming. We have created and conducted a series of integrated robotics classes for children aged from 10 to 16. The organizational condition for the session were next. Variable composition of participants, a different technical and software basis, extended duration of sessions. The session have been held for over a year, once every 2 weeks. In the creation of projects materials from basic microbit project, NASA research project, and Hacking Steam Microsoft project were used. Each project includes a prototype creating stage. The project are chosen so that readily available materials found in every household can be utilized. The projects also have a medium-term duration designed for activities spanning 4 hours. Hence, they can be applied during school break, STEM camps, workshops, etc. Conducting sessions of this duration requires through preparation and planning. Different types of tasks should be altered to keep the children engaged and vary their activities. In the course of developing the sessions, we drew upon an extensive experience of the STEM school at Kherson State University, but encountered the following challenges. Lack of methodological literature in Ukrainian, the challenge of explaining the principles of sensors operation for certain technologies, for example, radio mobile communications, to students who have not yet studied physics or are engaged in online learning, lacking experience in conducting collaborative work. Limited budget for preparation, uh, long duration of sessions. Most robotic projects are designed to be completed within 4 hours. Therefore, to maintain children's attention over a long time, various types of activities and organizing of physical activity were used in each section. Variable group composition. Each session introduced students who came for the first time. Therefore, we use so-called icebreaker games for this purpose. The slides show several examples of completed projects, each of which had certain typical stages. The first stage is the introduction. At this stage, motivation is created, the task is set, and knowledge is updated. The problem is explored from various perspectives. Possible project implementation options are considered here, critical questions are defined, and good ideas for further construction are recorded. It is advisable to conduct icebreaker games at this stage. The second stage is modeling and prototyping. Depending on the project, the prototype can be the electronic source code based on microbits. In this case, the main theme of the research becomes the prescription and processing of information. The topic of sensors and characteristics, the transformation of physical signals into electrical ones. The fixation and the analysis. There are also projects where it's possible to build a design model prototype from readily available materials. Such a model is built to test the basic functionality of the created system. It stimulates the operation of real devices and facilitates understanding of basic design and engineering constructions. At that stage, experimental testing of the design and engineering ideas takes place. The variety of available materials allows operating with concepts such as construction reliability, joint stiffness, degree of freedom, etc. The third stage of programming, most of the present projects do not involve complex software implementations. Them modification allows conducting experiments, comparing indication under different input data and initial conditions. The final stage is discussion and summarizing. At this stage, this is necessary to update the information received, remind about new terms and concepts online, outline further steps for improving projects, and provide feedback on the completed projects. Description. For example, we provide the description for one of our classes, a description of automatic plant watering. Smart greenhouses are part of a concept of smart city. The use of smart greenhouses help to use resources more efficiently, increase production volumes, and automate manual labor. Then we discuss the following questions. What is precision? How does the person perceive information provided by the world? How do robots and devices perceive their surrounding environment? A limitation of prescription. Can humans and robots always correctly determine indicators? Information processing. Then introduction of to microbit is specifically designed for teaching programming and electronics, and does not require mandatory prior programming knowledge. Construction of the irrigation model, creating the design and prototype of the irrigational system based on a lever, building a moisturizer measurement scheme, testing the system. Introducing to the servo motor, its programming and system testing. The irrigation system design may include a motor that activates when the soil lacks sufficient moisture. The motor can set a pump in motion to water the plant. And summary, definition of new terms and concepts are updated. Improvements to the project can be made by using pumps of different type. Since parents pick up the children at the end of the session, the students conducted a small presentation for them explaining what and how was implemented and what could be improved. The analysis of publication also revealed educational losses, especially in the study of mathematics due to global challenges. These circumstances significantly increased migration worldwide. However, the analysis of scientific literature confirmed the positive impact of STEM education on migrant children, taking into account the analysis of scientific sources and our own many years of experience in developing educational materials and conducting classes in the STEM school of Kherson State University. We had developed and conducted sessions for children from Ukraine as part of the volunteer project Ukrainian Hacker School. The purposed experience can be used refined and expanded by teachers, club leaders, students, and adapted for different targets or age groups. Thank you for your attention.